Hello students, today we will start the fourth lecture of unit and measurement, which is related to dimension and dimension analysis. Uh, Now we'll start one question. If we ask add these two number 5 kg plus 3 meter, can we add it? No. Answer is no. Because physical quantity must have the same nature. You can add, this is the unit of mass, this is the unit of length, so you cannot add this one, mass and unit of length. Only same, it should be same properties. Length, either it will use all are length or length, all should be mass. Okay, for this we are getting the dimension. The dimension is the physical quantity in terms of fundamental quantities. What are the fundamental quantities? Length, mass and time. So length, and the dimension symbol is within the third bracket L, third bracket M, third bracket T. And these quantities cannot be derived from the other quantities. Okay. So this is the fundamental quantity. And derived quantities, we know that, suppose for example, one term velocity equal to displacement by time. So velocity, the dimensional formula, what is the dimensional formula? Velocity, dimension of displacement is L and time is T. So that equal to L T to the power minus 1. Similarly, acceleration velocity by time, velocity is L T to the power minus 1 divided by T. So L T to the power minus 2. Now, where the dimension formula are used should be application for unit of physical quantity, dimension formula. Here what you have to do, whatever the physical quantity you just expressed in terms of mass, length and time, and general formula will be m to the power a, l to the power b, t to the power c. Suppose we have find out the dimension of force. Force, what is the formula? Force equal to mass into acceleration. Dimension of mass is m and acceleration is L T to the power minus 2. So you express this will be m L T to the power minus 2. So what will be unit? You convert in m kg, L meter and T second. So it is kg meter second to the power minus 2. And here one thing you remember, that dimension formula tell us how quantity depends on fundamental quantities. We are going to one example. Here the period of oscillation of simple pendulum depends on length, mass of the bob and acceleration due to gravity. You have to find out the expression of the time period. Now we express in general, it is the L, we are taking L to the power a, m to the power b, g to the power c. Okay, so and these proportion constant, k is the proportion constant which have the no dimension, dimensionless proportion. So t equal to L to the power a, m to the power b, g to the power c. Now L means length, dimension is capital L, m mass, dimension is capital M, and g acceleration due to gravity. So dimension equal to L T to the power minus 2. Now here is t, so dimension is t. Both side you just put this one and you get the value of b, no m is here, so b equal to 0. L to the power a plus c equal to 0, and t that equal to 2c minus 2c, so minus 2c equal to 1. So here what we are getting is, after solving that, we are getting a equal to half, b equal to 0, c equal to minus half, and substitute this value, then t equal to k into root over of L by g. Similarly, another a wavelength of meter waves depends on the Planck's constant, mass and velocity. Using the dimension of finding the formula. Okay, so here we are taking simple relation. Whatever the variable is given, to the power a, to the power b, to the power c. Okay, lambda wavelength, so dimension will be L. Dimension of the k is the dimensionless constant. So here dimension of Planck's constant is m L square t to the power minus 1, and m dimension is m, and this is the frequency, this is the velocity dimension is L t to the power minus 1. Okay, and substitute, after solving this we get a plus b equal to 0, both side, uh, 2a plus c equal to 1 minus a minus c equal to 0. And so again solving, we get the value of a equal to 1, b equal to minus 1, c equal to minus 1, and substitute the we are getting. And if you express in terms of different value, there v velocity, a force, t time, then so the fundamental, it is the fundamental, then express energy in terms of Vf and T, in terms of Vft. Here you see, whatever given, we have taken that equal to the formula, dimension formula is a to the v to the power a, f to the power b, t to the power c. Okay, so energy will be expressed this one, and we know that the energy, dimension of the energy equal to m L square t to the power minus 2. Okay, now you put the value of v, f and t. Okay, after putting this one, we get this one. Okay, so here you just get a plus b equal to L means 2, a minus 2b plus c equal to a minus 2b equal to minus 2, and b equal to 1. So if b equal to 1, obviously a equal to 1 and c equal to 1. Then you substitute the value of here a, b, c. So energy will be in terms of some constant will be there in terms of b, f, t. Another use is that convert of the physical quantity in one system from another system. Okay, we know that nu, n is the numerical value, u is the unit, nu is also constant. So nu equal to constant. Dimension formula of quantity is m to the power, any physical quantity, m to the power a, L to the power b, t to the power c. So in one system n1 u1 and another system n2 u2. As this is constant, so n1 u1 equal to n2 u2. Okay. Here n1 you can take that equal to in terms of this unit, n1 will be same. Unit u1, it is the dimension formula we can express m1 to the power a, L1 to the power b, t1 to the power c. Similarly, this is m2 to the power a, L2 to the power b, t to the power c. So if you find the n2 equal to what will be n2 equal to n1 and m1 by m2 whole to the power a, L1 by L2 whole to the power b, t1 by t2 whole to the power c. Now we have taken one example. Convert Newton into dyne. That means what will be the 1 Newton and 1 dyne relation. Okay. Here, when we got this one, what is the equation? Equation, this is the force. So what is the dimension formula of force? Dimension formula of force equal to m to the power 1, L to the power 1, t to the power minus 2. That means a, b, c. 1, b equal to 1, c equal to minus 2. And two system, we write two system. One is the SI system kg and CGS system. So m1 equal to 1 kg, L1 equal to 1 meter, t1 equal to 1 second. Here m1 equal to 1 gram, L2 equal to 1 centimeter, t2 equal to 1 second. Okay. So you just take the formula, this is the formula, and substitute. And you substitute by putting the all unit here. Okay. After then you convert kg into gram, meter into centimeter, second. Okay. Then gram will be cancelled, centimeter will be cancelled, and final result will be 10 to the power. There is the 10 to the 3, 10 to the power 2, so it will be 10 to the power 5. Okay. And third one is the check the correctness of the physical equation. Suppose this is a homogeneity where we have to follow the homogeneity of the dimension. Homogeneity means whatever the dimension here or the plus or minus what will be there, all will be same dimension. The homogeneity. Here you see we have taken the dimension of this s. S means displacement, so dimension will be LT dimension. L means ut. U means velocity, so it will be LT to the power minus 1 time t multiplied the dimension to L. So this dimension is L. Here half t square, half is the dimensionless quantity, and here at square, a dimension acceleration, at to the minus 2 and t square. So multiply the 2. So it is seen that dimension for these and these and these are same. So dimension of LHS equal to dimension of RHS. Now what are the limitation of the dimension? Here you see dimension cannot analysis the dimension numerical value. What are the numerical value at constant? It cannot be analysis. And it cannot work with the trigonometric function, exponential function, logarithmic function. It cannot work. And it cannot distinguish the same dimension. Suppose I am given work and torque. Both are same dimension. It cannot say which one is the work and which one is the torque. Okay. Thank you.